So next method is solving system of linear equation. Okay, a system of linear equation having at least one solution is said to be consistent. A system of linear equations having no solution is said to be inconsistent. That is, for example, this is a system of linear equation. Okay, there is three set of equations with three variables. Okay, so this equations to be consistent means if it has a solution, that is, we will get the values for x1, x2, x3. If we didn't get the values for x1, x2, x3 means the system of equations should be inconsistent. Okay, this we'll see later. Now we'll see matrix inversion method. Okay, solve this system of equations using matrix inversion method. Okay, so this is the given problem. 2x1 plus 3x2 plus 3x equals to 5. x1 minus 2x2 plus x3 equals to minus 4. 3x1 minus x2 minus 2x3 equals to 3. So this is the given question. This is the system of linear equation. So solution. First, the matrix form of the system is Ax equals to b. This is of the form A into x equals to b. Okay, where A is, write the coefficient of x1, x2, x3 each equation. Okay, so first equation is coefficient of x1 is 2 and coefficient of x2 is 3. x3 also 3. So write first row as 2, 3, 3 and second row as 1. That is x1. Before x1 no nothing is there, so it has assume as 1 into x1. So 1. So here minus 2 is there, so write minus 2 is also 1, nothing is there, so 1 x3 1. If here x3 is not present means we simply put 0, but here x3 is there, so 1 x3. Okay, so here 3 is there, 3, so minus 1 is there, minus 1, so minus 2 is there, 2. This A into x means x1, x2, x3. B, there is a solution is the B. So 5 minus 4, 3. So this, the given equation can be written as like this. Okay, so now we are going to find the inverse. To find the inverse, first we have to find the determinant of the particular matrix. So determinant of A equals to 2, 3, 3, 1 minus 2, 1, 3 minus 2, minus 2. So already we know how to find the inverse of the matrix. The same method we are going to apply here. So the formula for inverse is A inverse equals to 1 by determinant of A into adjoint of A. So we have to find what is determinant of A and adjoint of A. So first the determinant of A is 2 into, so minus of 2 is 2 2s are 4, 1 1s are minus 1, so plus 1. So 3 is there, minus 3 into here 2 1s are minus 2, 1 3s are 3, plus 3 is there, so we have to put minus 3, and plus 3 into 1 1s are minus 1, 3 2s are minus 6 there, so plus 6. So 2 into 5 minus 3 into minus 5 plus 3 into 5. So 2 5s are 10, 3 5s are 15, 3 5s are 15, so 40. So determinant not equals to 0. If the determinant is equal to 0 means A inverse does not exist. So here determinant is not equal to 0 means, so definitely we will have A inverse. So formula A inverse equals to 1 by determinant of A into adjoint of A. So determinant of A is 40. So 1 by 40 into adjoint of A. Adjoint of A means we have to find the cofactors, that is minors of each and every element. Okay, so 2 for 2, 2 2s are 4, 1 1s are minus 1, so plus 1, so 4 plus 1. For 3, 1 2s are minus 2, 3 1s are 3, minus 3. So for this 3, 1 1s are minus 1, 2 3s are 6, minus 6, so plus 6. And for this 1, so we have to leave this corresponding row, corresponding column. So 3 2s are minus 6, so 1 3s are 3, minus 3, so plus 3. And for this minus 2, so we have to corresponding column, corresponding row. So minus 2 means 2 2s are minus 4, and for this, right, 2 2s are minus 4, 3 3s are 9, plus 9 is there, so minus 9. And for this one means 2 1s are minus 2, 3 3s are 9, so minus 9. And for this 3 1s are 3, 2 3s are 6, minus 2 is there, so minus 6, so we have to put plus 6. And for this minus 1, 2 1s are 2, 3 1s are minus 3. And for this minus 2, 2 2s are minus 4, 3 1s are minus 3. So obviously we have to put the sign simultaneously, plus minus plus minus plus minus plus minus plus, and finally transpose. Okay, transpose means you have to change this column into this row, this column into this row, and this column into this row. So 4 plus 1 5 plus 5. Okay, and minus 6 plus 3 minus 3, so minus into minus plus, so plus 3, 3 plus 6 9, so minus 2 minus 3 minus 5, so minus into minus plus 5, and then we see that this minus 4 minus 9 minus 13, 2 minus 3 minus 1, so minus is there, so plus 1, so minus 1 plus 6 plus 5, minus 2 minus 9 minus 11, so minus into minus plus 11, minus 4 minus 3 minus 7. So now applying this x equals to A inverse B. So the given system is Ax equals to B. So we just move A into that side. So x equals to A inverse B. So you have to find this value. Okay. This value means A inverse into B. So A inverse already this, and B is the from the equation, given equation, this is the value for B. Okay. So we have to multiply this. Okay. Put 1 by 40. So 5 5s are 25. 3 4s are minus 12. 9 3s are 27. 5 5s are 25. 13 4s are 52. 1 3s are 3. 5 5s are 25. 11 4s are 44. Minus 44. 7 3s are minus 21. So 1 by 40. 25 minus 12 plus 27. So 40. 25 plus 52 plus 3. 80. 25 minus 44 minus 21 minus 40. So divide by 40. 40 by, that is 1 by 40 is there. So divide by 40 each element. So 40 by 41. 80 by 42 minus 40 by 40 minus 1. So this is the value of x1, x2, x3. So solution is x1 equals to 1, x2 equals to 2, x3 equals to 2. So this is the method how to find the solution using matrix inversion method. Okay, for this we have to know how to find the inverse. Inverse means we already saw how to find the inverse of the matrix. So after finding the inverse of the matrix, we just apply this method and then easily find the solution of the given system of linear equations. Next method is Cramer's rule. This rule can be applied only when the coefficient matrix is a square matrix and non-singular. Okay, that is, the matrix should be of the same row and same operator. That is called square matrix. That is either 3 by 3 or 2 by 2 or 4 by 4. For this matrix only we are going to apply Cramer's rule. Okay, so given equation solved by Cramer's rule, the system of equation x1 minus x2 equal to 3, 2x1 plus 3x2 plus 4x3 equal to 17, x2 plus 3x3 equals to 7. So Cramer's rule means first we have to find the determinants. Okay, first determinants in general, determinants of the equation determines del. Okay, so in first equation coefficient of x1 is 1 and coefficient of x2 is minus 1, x3 is not there, so put 0, and here x1 coefficient of x1 is 2, for x2 is 3 and for x3 is 4, and here x1 is not there, here x1 is not there, so put 0, and x2, for x2 1 is there, and for x3 2. So this is the given equation. We have to find the determinant. Okay, so this method, this is the solution for first equation 3 17 7. Okay, so we have to find the determinants. Or means first we have to find the determinant of this, and next del 1 means we have to change this 3 17 7 into first column, and del 2 means we have to change this into second column. Del 3 means we have to change this into third column. So like this we have to find the 4 determinants value. Okay, first define the determinants of this matrix. Okay, so 1 3 2s are 6, 4 1s are 4, 6 minus 4, so minus there, so minus into minus 1, 2 2s are 4 minus 0, so 0 is there, so obviously 2 into 2 4 0, so 0 into anything is 0, that is 2 1s are 2, so 0, so 6 minus 4 2, so 4 0 equal to 6. Determinant not equal to 0. First, if the determinant is equal to 0 means the matrix is a singular matrix, so we are not able to apply the Cramer's rule. So the determinant of this, that is given matrix, should be not equals to 0. Then only we are able to find solutions using Cramer's rule. Next, del 1. Del 1 means we have to change these 3 values into first column. Okay, so change first column into 3 17 7. So 3 17 7 remaining right like this. Okay, so determine 3 into 3 2s are 6 minus 4 1s are 4, 6 minus 4 minus 1 is there, so minus into minus 1 into 72s are 34, 7 4s are 28, so 0 or place 0 into anything 0, so 17 minus 21, so this becomes 0, 6 minus 4 2, 34 minus 28, 6. So minus 2 minus plus 1, 0. So 6 plus 6 equal to 12. So next is del 2. Del 2 means we have to change second row as that solution 317 and write, sorry, second column in 317 and write first column and third columm as it is and find the determinant. Okay. So 1 into 17 to the 34 minus 28 minus 3 into 2 2s are 4 minus 0 plus 0 into 14 minus 0. So obviously 0 into anything 0. So 34 minus 28 6, 4 minus 0 0 plus 0. So 6 minus 12. So minus 6 and del 3. Okay, we have to change third column as the solution 317 7 and write first column and second column as it is and determinant of this 1 into 3 7s are 21 minus 17 minus into minus 1 into 7 2s are 14 minus 0 plus 3 into 2 minus 0. So 1 into 4 plus 1 into 14 plus 3 into 2. So 4 plus 14 plus 6 equals to 24. So by Cramer's rule, this is the formula for finding x1, x2, x3. x1 means del 1 by del, x2 means del 2 by del, x3 means del 3 by del. So this is the formula for Cramer's rule. So to find the Cramer's rule, we have to find the determinants. So this is a 3 by 3 matrix. We have to find del 1, del 2, del 3. If it is a 4 by 4 matrix means we have to find del 1, del 2, del 3, del 4. And if it is a 2 by 2 matrix means we have to find del 1, del 2. Here the question is a 3 by 3 matrix. So up to del 3 we will find. So formula for x1 is del 1 by del. So obviously the del should be not equal to 0. Okay, if del is 0 means so this is invalid. So that's why for Cramer's rule the del value should be not equal to 0. So del 1 we already found that 12 by 6 2 and del 2 minus 6 is there, minus 6 by 6 minus 1 and del 3 24 by 6 4. Solution is x1 equals to 2, x2 equal to minus 1, x3 equals to 4. So this is the method of finding the solution using Cramer's rule. So next method is Gauss elimination method. Okay, here also system of linear equation. We have to find the solution using Gauss elimination method. Previously we had seen that how to find the solution of the system of linear equation using matrix inversion method, Cramer's rule. This is Gauss elimination method. So thus given the question as solve the following system of linear equation by Gauss elimination method. 4x plus 3y plus 6z equals 25, x plus 5y plus 7z equals 13, 2x plus 9y plus z equals to 1. So for Gauss elimination method, we just change the given matrix into row echelon form. That is, transform the augmented matrix to a echelon form. Augmented matrix means this is the augmented matrix. Okay, we have to write x, y, z. Either in question they mention x, y, z or x1, x2, x3. So whatever it is. So what mention means we have to find the solution of the particular variable. Here x, y, z is mentioned. So coefficient of x is, this is kept as first row, second row and third row. Write the coefficient 4, 3, 6 and 25. X 1, 5, 7, 13, 2, 9, 1, 1. Okay. To separate this, I just put bar. Okay, this is the augmented matrix. We have to change this into row echelon form. Okay, after row echelon form, we'll easily find the solution of the given equations. Okay, so obviously, if the first element is 1 means, then it will be simple. So I just simply change this into row 1 and this into row 2, like R1 implies R2. So just write R2 as R1 and R2 as R1 and R1 as R2. Okay, so 1 5 7 13 4 3 6 25 2 9 1 1. So now we are going to make below 1, that is below 1, 4 to as 0 by using the elementary operation. So here 4 is there, obviously 4 minus 4 0, and here 2 is there, obviously 2 minus 2 is 0. So multiply R1 by 4 and subtract from R2, and multiply R1 by 2 and subtract from R3. So I write R2 as R2 minus 4R1, R3 as R3 minus 2R1. So write R1 as it is and R2 is R2 minus 4R1. R2 4 minus 4R1. 4 minus 4 0. 3 minus 4R1. So 5 was a 20. 3 minus 20. 3 minus 20 minus 17. 6 minus 4R1. 7 4 is 28. So 6 minus 28 minus 22. So 25 minus 4 R1. Okay. So 25 minus 4 into 13 will get minus 27. Similarly, R3 equals to R3 minus 2 R1. So 2 minus 2 R1 0. So 9 minus 10 minus 1. So 1 minus 2 R1. 2 into 7. So 1 minus 14 minus 13. So 1 minus 13 into 26. So 1 minus 26 minus 25. Okay. So here we just make this as 0. Okay. Now we just, here a lot of minus is there. So we simply divide this two rows by minus or multiply minus, whatever it is. Then it will becomes plus sign. Okay. That is R2 equals to R2 by minus 1. R3 plus R3 divided by minus 1 or multiply by minus 1, whatever it is. We just change this minus into plus. So we have to simply do for all row 2 and row 3. So the matrix becomes 1, 5, 7, 13, 0, plus 17, plus 22, plus 27, 0, 1, 13, 25. So now we have make this to be 0. That is below the 1 to be 0. That is first non-zero element in first row. And first non-zero element in second row is 17. So we have to make below this 17 this to be 0. This is the method of row equivalent form. So this to be 0. So using R2. Okay, here 1 is there, here 17 is there. So multiply by 17 and subtract from 17, it becomes 0. So the operation is R3 equals to 17 R3 minus R2. Okay, write R1 as it is, R2 as it is, R3 is 0 minus 17 to 0. That is 17 to 0, 0 minus 0, 0. So 1 into 17, 17 minus 17, 0. So 13 into 17 minus 22, 199. So 25 into 17 minus 27. So 398. So this is the row echelon form. Okay. So there is row echelon. This is row echelon form. Okay. That is the diagonal. Below the diagonal, the element should be 0. So now we'll use the back substitution method. That is, write the equation x, y, z. That is 1x plus 5y plus 7z equal to 13. 0x. So no need to mention x in second equation. 17y plus 22z equals to 27. So 0x plus 0y plus 199z equals to 398. So back substitution method means we have to find from this equation 3. 199z equals to 398. So z equals to 398 by 199, which is equals to 2. So substituting z equals to 2 in equation 2. Okay, that is 2 in 2. We get 17 into y plus 22 into 2, 27. So 71 equal to 27 minus 44. So 44, it goes here means minus 44. So 17y equal to minus 17. So y equals to minus 17 by 17. So minus 1. So we find the z value and y value. Substitute this in equation 1. So substitute is equal to 2, y equal to minus 1 in equation 1. We get x plus 5 into minus 1 plus 7 into 2 equal to 13. So x equals to 13. This will go this side means, so 5 into minus 1 minus 5. So that side means plus 5. So 7 into 2, 14 plus 14. That side means minus 14. So x equals to 13 plus 5 minus 14. So x equals to 4. So solution is x equals to 4, x equals to minus 1, z equals to 2. So this is the method of finding the solution to the system of linear equation. So next method is consistency of system of linear equations by rank method. The given problem is test for consistency of the following system of linear equation, and if possible solve x plus 2y minus z equal to 3, 3x minus y plus 2z equals to 1, x minus 2y plus 3z equals to 3, x minus y plus z plus 1 equal to 0. Okay, so if the given system of equation has a solution means, then this should be consistent. If this equation does not have a solution means, then it should be inconsistent. Okay, so just we have to find the solution for the system of linear equation by rank method, and then write the consistent or inconsistent. Okay, so here solution, the number of unknowns is 3. Here 3 unknowns, there is x, y, z, 3 variables is there, so 3 unknowns. So the matrix form of the system is ax equals to b, where a equals to coefficient of x, y, z. This is first row, second row, third row, fourth row. So x is 1, y is 2, z is minus 1. So second equation, x is 3, quotient of y is minus 1, quotient of z is 2. And third equation, x is 1, y is minus 2, z is 3. And fourth equation, x is 1, y is minus 1, z equals to 1. And here plus 1 is there, we have to move this to this side, then equal solution. So write this as b is 3 1 3 minus 1. We are not supposed to write 0 because here 1 is there, so we just simply move this one to this side and write as minus 1. So x is x y z. So we have to write the given system is ax b, ax into b, okay, and write the argument matrix, okay. So argument matrix a by b. So write a matrix as it is and b solution like this, okay. So this is the augmented matrix, okay, a by b, where a is this and b is this. So apply Gauss elimination method on a by b, we get this. We have to apply Gauss elimination method. Elimination method means we have to change this into a row echelon form. So the first non-zero element in row 1 is 1. So first step is we have to make the below 1 to be 0. That is 3 1 1 to be 0. So using the elementary operation, that is here 3 is there. So 3 minus 3 is 0. So multiply for R2, multiply R2 minus 3 R1. And this 1 is there, here also 1 is there. So simply R3 minus R1. So here also 1 is there. So simply R4 minus R1. So this is the elementary operation. After this becomes 0, okay, and we'll see what happens this. Using these operations, we'll get the matrix, that is R2 equals to R2 minus 3 R1, R3 equals to R3 minus R1, R4 equals to R4 minus R1. So this is the first row, 1 2 minus 1 3, 0 minus 7 5 minus 8, 0 minus 4 4 0, 0 minus 3 2 minus 4. So we just simply change this into plus sign so that it will be easier to make this term as 0. So multiply this 3 rows by minus 1. So like this operation. So write R1 as it is and R2 as 0 plus 7 plus 5 is there, minus 5, 8 is minus 8 is there, plus 8, and 0 plus 4 minus 4 0, 0 plus 3 minus 2 plus 4, okay. The first we already changed this, the below the first non-zero element in row 1. So below this element we change 0. Next step is the first non-zero element in row 2 is 7, okay. This row 2, this is the first non-zero element. We have to make the below to the 7 to be 0, okay. So for this here using R2 we have to make 4 and 3 as 0. Obviously the common term is not there. So 7 4s are 28, 4 7s are 28. So multiply and subtract will get 0, okay. That is write R1 as it is, R2 as it is, so R3, okay. Here 4 is there, 7 is there. So R3 means 7 R3 minus 4 R2, that is multiply R3 by 7 and R2 by 4 and subtract this from this, okay. We'll get this term. So 0 0, so 0, 4 into 7 28, 7 4s are 28, 0. So minus 4 into 7 minus 28, 5 4s are 20, minus 20, minus is there, so plus 20, minus 28, plus 20, minus 8, and here 0 is there. So 0 into 7 0, 8 4s are 32. So 0 minus 32 minus 32, and here R4 equals 7 R4 minus 3 R2. So multiply R4 by 7 and multiply R2 by 3 and subtract this from this, will get this term, okay. 0 minus 0 0, 3 7s are 21, 7 3s are 21, 0, minus 2 into 7 14, minus 5 into minus 3 plus 15. So minus 14 plus 15 plus 1. So 4 is there, 4 7s are 28, so 8 is there, 8 3s are 24. So 28 minus 24, 4, okay. So we just change the number below to 7 0, okay. So next is we have to, if possible, we have to change the below. This is the first non-zero element in row 3. We have to change this below to 8 is 0. Before that we just simply eliminate. Here minus 8 is there. So if we divide by minus 8 means it becomes 1. Then it will be easier for us. So write R1 as it is, R2 as it is, and divide this R3 by minus 8. So that 0 is become 0. Write 0 as it is. Minus 8 by minus 8, 1, minus 32 by minus 8, 4. So write R4 as it is. Okay, we have to make this to be 0. That is first non-zero element. R3 is 1. We have to make this as 0. Okay, right? R1, R2, R3 as. So using the operation, simply subtract R3 from R4. Okay, that is R4 equals to R4 minus R3. So 0 minus 0, 0, 0 minus 0, 0, 1 minus 1, 0, 4 minus 4, 0. Okay, this is the row echelon form. Okay, here the number of non-zero rows. Okay, this is non-zero row, this is a non-zero row, this is also a non-zero row because 1 and 4 is there. This is a 0 row. So this is a 0 row because all the element in this row is 0. Here 2 element is non-zero. So 3 element is non-zero. Here all the element is non-zero. So 3 non-zero rows. There are 3 non-zero rows in the row echelon form of AB. So rank of this is 3. Okay. So the row echelon form of A, that is, this is the A matrix. So for this also 3 non-zeros. Okay. So rank of A equal to 3. So the rank of A by B must equal to rank of A. The rank of A and rank of AB both are equal. If this is not equal means then the system is inconsistent. We simply write inconsistent. So for consistent matrix, this both should be equal. This is called the important theorem. Okay. So here both are equal. So from the echelon form, we write the ecosystem. Okay. This is the first row, second row, third row, fourth row. Right, like this, in this form of equations. So x plus 2y minus z equals to 3. 7y minus 5z equal to 8, z equals to 4, 0 equals 0. So this is meaningful. So obviously 0 equals 0. So take by the method of back substitution. Z equals to 4. So z equals 4. Substitute z equals to 4 in equation 2. 7y minus 5 into 4 equals to 8. Okay, like this. 7y equals to 8. Minus 20 is there. So plus 20. So 7y equals to 28. So y equal to 28 by 7, 4. So substitute y equal to 4, z equals to 4 in this first equation. So x plus 2 into 4 minus 4 equals to 3. So x equals to 3. So 8 minus 8 plus 4. Okay, so x equals to minus 1. So the solution is x equals to minus 1, y equal to 4, z equals to 4. Hence the given system is consistent and the solution is unique. Okay, that is, if the system has a solution, this is consistent. That is, if the condition is both the ranks should be equal, then only the system is consistent. Otherwise, this is inconsistent.